Okay, good morning, afternoon, or evening, everybody. Welcome to the Harmony Services Subset Regrid and Reproject Data in the Cloud ESDIS Data Training webinar. This is your host, Jennifer Brennan. It is 2 p.m. Eastern Daylight Saving Time, so we're going to go ahead and get started. And what I'd like to do first is begin today's webinar with a few logistics. To ensure the best audio experience, all participants have been placed in silent mode, but if you have any issues or you have any questions, please enter them into the Q&A panel rather than the chat located on the right side of your screen. If you do not see the Q&A panel, what you can do is click on the three dots at the bottom of your screen to pull up your panel options and then insert a check mark next to the Q&A option. A quick word about the chat. Participants will have the capability to chat with the hosts and presenters, but not all participants. So if you have any questions, and for the benefit of all participants, again, please enter them into the Q&A panel on the right side of your screen rather than the chat. Today's webinar is being recorded. The recording will be made available online within a week of completion. And then once completed, what I will do is I'll send an email to all registrants and participants that includes links to both the recording and presentation slide decks used within today's webinar. As far as timing is concerned, today's webinar will be 1 hour long with 45 to 50 minutes allocated to the presentation and live demonstrations. A 15-minute Q&A period will follow, and depending on the volume of questions we receive, we may extend the Q&A session, but we will have a hard cutoff of 3:15 p.m. Eastern. During this afternoon's webinar, we have one speaker and one Q&A panelist. Our speaker for this afternoon is Christine Brown-Stevenson. Christine is a software engineer at NASA's Level 1 and Atmosphere Archive Distribution System, Distributed Active Archive Center, or LAADS DAAC. She'll kick us off with an introduction to LAADS DAAC and NASA Harmony services. And then from there, we will discuss the subset, band name, and Geoloco services within Harmony. Christine will then go over available collections and wrap out her presentation with live demonstrations that make use of these services for accessing MODIS data. Once Christine is finished with her demonstrations, what we'll do then is I'm going to open up the final optional polls and we'll jump directly into the Q&A session. Our Q&A panelist for this afternoon is Doug Newman. Doug is the Science Data Systems Lead for the ESDIS project, or Earth Science Data and Information System, at Goddard Space Flight Center. Before I toss it over to Christine, I'd like to say just a couple of words about this afternoon's Q&A session. We will try to address all questions within the time allotted, but if we're not able to address your question during the Q&A period, our speakers will be able to follow up with you offline. So with that, it is my pleasure to introduce today's speaker, Christine Brown-Stevenson. Christine, and with that, what I will do is I'm going to stop sharing my screen and toss it over to you.
Hi, everybody. I'm going to start sharing my screen. Can you guys hear me okay?
The audio is a little bit low, actually.
Okay. How about now?
That's much better. Thank you so much.
Okay. Share my screen. Oh. So it says, ask the current presenter to close the poll, then change the presenter.
So you should have the presenter role now. You should be able to share. Thank you.
Excellent. So, hi, everybody. Like Jennifer said, my name is Christine Brown-Stevenson. I'm going to present transforming MODIS data in cloud with Harmony services to subset, regrid, reproject, resample using Geoloco and subset band name. As Jennifer said, I'm going to go through what is LAADS DAAC, what are Harmony services, subset band name service, Geoloco service, the available collections for the two services above, and end out with a live demonstration. So what is LAADS DAAC? As Jennifer said, LAADS stands for Level 1 in Atmosphere Archive Distribution System, Distributed Active Archive Center. We're based in Greenbelt, Maryland, and we process Level 0 to Level 4 data. So, like I said, here are the examples of the data we have. Level 0, level 1, atmosphere, which shows cloud, vapor, aerosols. We have airborne data, land data, and applications for the data. The instruments that we receive data from are the Aqua Modis, the Terra Modis, SMPP, JPSS1 viewers, MBSAT mirrors, Sentinel-3 OCI, and Sentinel-3 SOSTR. So, what are Harmony services? Harmony is a platform that's based on NASA Earthdata system that allows transformation of cloud-based data. It allows seamless analysis of Earth observation data from different NASA data centers. So, all NASA data centers are able to put their data in the cloud, and Harmony allows transformation on those cloud-based data. So, what are the key benefits of Harmony services? So, off the top, it saves you time, it saves you download data, the reduction of download data, and it saves you money. So, it increases usage and ease of use of cloud data. So, you can, while the data is already in cloud, you can do transformations with Harmony services with the cloud data. It allows consistent access patterns across data centers. So allow data centers to use the Harmony services with their cloud data, reduction of services. So the user is only getting the data that they want or need and not the whole output file and not the whole data file. Analysis ready data delivery. So since the data is in a format that they already need, they're ready to do analysis. And same with the reduction time to science. So it's already in a format that is wanted, and there you can already do analysis or science with the data that's there. And there's also community development opportunities. So who could use Harmony services? Basically, anyone with an Earthdata login account is able to use Harmony. Is available to all registered users. You can easily access it with Earthdata search, or you can use any programming language that is able to do curl requests to interact with the Harmony API. There's integration with NASA data workflow, so it's already integrated into the cloud data. Wrong way. So what is subset band name? Subset band name subsets variables by name and band of HDF4, HDFBOS2 data. The target is modest 6.1 collections that are in the HDF4, HDFBOS2 format, but other collections that are in HDF4, HDFBOS2 format works as well. It reduction of file size because you're only getting the names or the bands / or the L1B bands that you want, and the band differentiation by wavelength ranges. So each band has a different primary use, and you're able to subset your L1B bands by that way. So why use it? You should use subset band name because you're reducing the amount of data or bandwidth by reducing the file to the bands that you want to use or the variables that you want to have for processing. The reduction of data volume, say bandwidth, like I said before, the user is able to get the data that they want using the name and band. Create analysis ready data. Like I said, it's already in a format that the user wants, and takes time saving for researchers. So the researchers do not have to do the subsetting on their own. On their own, they can use the Harmony service to get the data that they want. So modest L1B has spectral bands with specific applications, which I will go on the next slide. So here is the list of L1B bands. It says 1 to 36, but it's technically 38 with 13 low, 13 high, 14 low, 14 high, but they are labeled 1 to 36. So these on the right-hand side are the band numbers. So these are the band numbers that you will use to do the band subsetting of L1B products. On the left-hand side are the primary use for each band number. So as you see, 20 to 23 is surface cloud temperature, while 29 is cloud properties and 30 is ozone. So each band each own primary use. So what is Geoloco? Geoloco is a service that does reprojecting, resampling, regridding, and spatial subsetting of HDF4, HDF-EOS2 files. Its primary target is also modest 6.1 collections that are in the HDF4, HDF-EOS2 format, but other collections can be used with their service as well. The benefit is that it works well with HDF4, HDF-EOS2 file formatting. And one function that it does has is that it's able to download the geolocation file directly from S3 that's needed for calculations. The geolocation files, the geolocation collections are mod 03 and MID, mid 03. So why use Geoloco? So you should use Geoloco because you can customize your data set by spatial subsetting, by your area of interest. You reduce your download data volume by having to just having your data reduced to area of interest. Save time and bandwidth. The users can already has the data in a format that they want. Like if they do their reprojection and then subset by spatial and deliver analysis ready data because it's already in a format that the user requested. And it works well with L1B to L4 granules. L1B and L2 are swaths, but with Geoloco, when L1B and L2 go to Geoloco, it'll automatically be reprojected to gridded geographic if there's no projection selected. So the service chain of subset band name Geoloco. Subset band name and Geoloco both perform variable subsetting in the past. So now it's split out to each distinctive transformation per service. So subset band name performs variable band subsetting, while Geoloco does reprojection, regridding, resampling, and spatial subsetting. It reduced the transformation, eliminated the transformation duplication, and it streamlined the workflow for the users. And I will show this later on in the demo. So here are the available collections that is ready for using Harmony Services, subset band name, and Geoloco in the cloud. As you see, it says MO/Y. So MOD is mod, that stands for Terra, and MID is mid, that stands for Aqua. So there are Terra and Aqua pairs for each data. And you see there's a lot of L1Vs, we have a lot of L2s, and then there's one graded, but I just added the rest of the graded collections to the service. Like I said before, those collections are available now for transformations in the cloud using subset band name Geoloco. And I just onboarded the rest of the LD collections to subset band name and Geoloco. So now I'm going to go over the Earthdata search, go over the demos. The first one would be Earthdata search, and the second one would be Jupyter Notebook using Harmony API calls. So this video is not going to work, so I'm going to back out of it. So as you see, this is Earthdata search, which is search.earthdata.nasa.gov. As you see, there's a world view right here. You are able to subset the world using a spatial polygon, a rectangle, a circle, spatial coordinate, or a shapefile. You can change your view of the world. Here you can zoom in and zoom out and zoom out. When you add a file to your project, it will be over here in your project area. Here's your user information right here. So just say I would just want to see what modest data is available for Harmony transformations in the cloud. I'll first click this gear, which means it's Harmony transformations available for the collections. Here is where the collections show. So I'm gonna next pick the modest instrument. This is Earthdata search. So as you see, there's a world view right here. You are able to subset the world using a spatial polygon, a rectangle, a circle, spatial coordinate, or shapefile. You can change your view of the world. Here you can zoom in and zoom out. When you add a file to your project, it will be over here in your project area. Here's your user information right here. So just say I would just want to see what modest data is available for Harmony transformations in the cloud. I'll first click this gear, which means it's Harmony transformations available for the collections. Here is where the collections show. So I'm gonna next pick the modest instrument. There we have it. So, and then lastly, I'm going to pick the organization as LAADS. So there you have it. These are the 16 pairs of Terra and Aqua collections that are available for processing in the cloud. Which is basically our cloud holding. So say if I want to do transformations on our cloud mesh product, which is the mod 35 LT, I'll put that in the search bar. And I'll click on the collections. That'll show me granules or files that are available to download or where they are located. I'm going to make a box on Florida because Florida is always easy to view. It's a recognizable coastline. In here, I'm just going to scroll to find a good swath of data that will allow me to subset the area, which I'm going to pick this one. I'm going to go to my project. Sorry, it's going to take a while for it to load. Oh, interesting. Okay, go ahead. Have our project. There we have it. I'm going to say customize with Harmony. I'm going to pick the Geoloco service. And I'm also going to pick the Cloud Mass SDS of variable. And I'm going to click download data and it'll kick it off to Harmony. So I'm going to Harmony workflow UI. I see it's being processed in Harmony. It goes to query CMR first to get the granule. It's going to go to subset band name to do the variable subsetting. Now it's going to go to Geoloco to do the spatial subsetting and to automatically reproject it to geographic projection. AC, it all passed. So there's sometimes I lag with it going back to the Earthdata search. So it might just need some patience before it pops up. So the download files will pop up in this area right here. As you see, it does take some time. Up there we have it. So now you have your output files. So Cloud Max has different layers. So you have 6 different layers that were split out by Geoloco. So I'm gonna pick Cloud Max 3. I am going to download it. I'm going to open up HF View. Going to open a file. HDF View is a good tool to open up files that are in HDF4, HDFVOS2 format. Here, open up the container folders, the grouping folders. I'm going to say open as, so you open as an image. Ha, we got a good image. It's awesome. Oh no. Okay. So I'm going to pick the rainbow palette to open up the image. And there you have it, the cloud mass over Florida using Harmony Services subset band name and Geoloco. So for the next demo, I'm going to use Harmony scripts or Harmony API calls with Jupyter Notebook. It's an introduction to basic Harmony basic scripts. Open source service integration. So it's a lot of open source. Harmony calls are open source using the Harmony Python package. Jupyter, there's Jupyter Notebook I'm going to use that does band subsetting with Geoloco. Well, with subset band name, and then pass it to Geoloco to do reprojection, regrading, resampling, and implementation in a custom script. So the disclaimer is that Geoloco and subset band name are not open source yet, so this Jupyter Notebook will not be available yet, but it should be released to open source soon. So here's my Jupyter Notebook. It has different descriptions in there. Here are the bands 1 to 36, but technically 38 with 13 low, 13 high. Here's a mod 021KL file specification that once had 36 bands, so it's nice to know what is in the file before you do transformations on it. Here is a blurb that says 13 high, you want to pin the number with a 9. Here's subset band name links. Here's a link to repository. Here's a link to the Jupyter Notebook, which would be nice to have. And here is some basic description of how the Geoloco service was tested. Here's a key quote that says you have to be pointing your AWS or your S3 to AWS US West 2. Here's a prerequisites that you have to set up your Harmony client according to production to use the credentials from local netrc file. And here are the Python packages that are used in this Jupyter Notebook / supporting notebooks helper. So it's Harmony Pi that's used for that is able to interact with Harmony API, S3FS to interact with AWS S3, PyHDF used to interact with HDF4 file, matplotlib to plot the output files, Carcipes helpful with the projections, NumPy working with arrays and data types, and Read to do parsing strings. So here I am setting up my packages that's going to use in my test case. Here is bbox or the original bounding box. Here's the client to set up your client to put to production. Here's the collection that is used to set up your collection that's going to be tested on. The environment used to put into production to tell the client which environment is used. Here's the request, or you set up your request to the Harmony API call, and dimensions I use for band subsetting. Here are some more helper functions that I'm created to help with the test cases to not clutter it up. So I'm going to press play. So here I'm setting up the Harmony client to point to the production environment. Here I'm setting up my S3 file system. And one important thing is I'm using the Harmony client to set up the AWS credentials, and I'm porting the region to US West -2. So this notebook itself has plenty of test cases, which we use to verify the service. So there are common parameters that are used between the different cells. So first I got the Florida bounding box. I had the geographic parse for a string. Interpolation is nearest neighbor. And here I have different resolutions that are converted to degrees since geographic is in degrees. So we're going to focus on testing this with our mod 021km or level 1B calibrate radiuses at 1 kilometer product. And we're going to use band subsetting with subset banding. So I'm going to split out band 6 through 10 from the mod 021km. As you see, as I said before, it has 36, well, technically 38 bands. I'm going to bring it down to 5. Bounding box of Florida, reprojection, pick geographic, interpolation nearest neighbor, and then I'm going to downscale the image by 2, so 2 kilometers, which is 0.018 degrees. So here I am setting up my collection for mod 021km and the granular ID for a file of mod 021km. You can find that information by searching the product, which is mod 021km, clicking the 3 dots on any file or a file that you want to use, and that will show you the collection ID, and it will show you the granular ID for a particular file. So that's how I get the collection ID and the granular IDs. Sometimes I have stale data in my output path, so sometimes I just delete the stale output data before I download the new data. Here I'm setting the request. The collection is mod 021km. The file is the granular ID is the granular of a mod 021km collection. Here I'm picking a geographic parse 4 string for projection. I am downscaling to 2 kilometer degrees. I'm picking interpolation nearest neighbor, and I'm going to subset the area by using the Florida bounding box. And using the dimension request, I'm requesting bands 6 through 10. So with this line, I am submitting my request, and it will wait for the files to be downloaded and then show you my downloaded files. Here, I kicked off the order right here. And if I go right back to the Harmony Workflow AI, as you see, it's running. Oh, it just finished. So it went through query CMR to get the granular file, and went to subset banding to do the band subsetting, and went to Geoloco to do the reprojection, regrading, resampling. As you see, the output files are starting to come through. So this output file was from subset band name, or not that one. This output file was from subset band name, and the rest of these output files were from Geoloco after the subset band name output file was passed to Geoloco. So when I grabbed all the output files, this line right here, I grabbed all the output files that I got, and I looked through the output files, and I displayed the band numbers for band 100, 500M, and band 1km ref SB, and I displayed the variables in the file. So as you see, band 500 has 6 and 7, and band 1km ref SB has 8, 9, and 10. And here are the variables that are in the file. So these variables, like latitude and longitude, are one of the bigger ones. So it has 36 layers for 36 bands, and to reduce it to 5 is really nice, so that the scientists doesn't have to search through all the data. So as you see, Earthview 500 aggregated 1km ref SB has 1 and 2 that corresponds 6 to 7, and then Earthview 1km ref SB has 1, 2, 3, which corresponds to 8, 9, and 10. And here are some of the output files. Output images. So, very nice to use. The Jupyter notebook, hopefully be able to get out soon with the open source. And I'm going to go back to my slides. So getting started, if you want to use subset band name with Geoloco and Harmony on Harmony services, you'll first need to do get your Earthdata login account. If you already have your Earthdata login account, that is great. You'll get to look through access through Earthdata search or look up some Harmony calls that are able to do curl requests for Harmony. Explore all available collections and try some basic scripts and examples. So that is it for me. Sorry, I'm in there a little bit early. So here are some helper links if you have any questions. And I guess I'll toss it back to Jennifer.
Well, thanks so much, Christine. And at this point, I'm going to open up the final optional polls. And we can open it up to any questions here. And so far, I haven't seen any questions in the chat, but just bear with me. Let me take a look in the chat here to see if there are questions. Let's see. Alrighty. All right. So just as a follow-up, while we're waiting for questions, I will send an email to all webinar participants and registrants that will include a link to both the reporting for this afternoon's event, as well as link to Christine's presentation slide deck. Okay, we can place that link to the slide deck in the chat again. Usually it takes a couple of days, up to a week for post-processing. So again, you'll receive an email from me in the week to come. All right, anybody have any questions? All right, excellent. All right, so the question is, this is a science question. Okay, but perhaps somebody from the LAADS DAAC could, this might require a follow-up offline because it's kind of outside of the scope of today's webinar topic. For this webinar participant, I'm happy to follow up. But let me go ahead and read this aloud and see if either Bhaskar or Sadashiva from LAADS DAAC have any input here. Is it possible to track specific processes such as the transcontinental transport of essential soil nutrients like phosphorus and nitrogen? How are such long-distance biogeochemical transport events monitored? For example, using satellite observations or data systems. The first thing I want to say before just seeing if anyone else as a panelist wants to weigh in, but certainly there are data products that can be used for this kind of work. But again, I think a more in-depth follow-up would be really useful for you. Did anyone else, any of the other panelists want to add to that comment?
This is Bhaskar here. My name is Bhaskar Ramachandran.
It's difficult to hear you, Bhaskar.
Okay, hang on. Okay, how about now?
That is wonderful. Thank you.
All right, thanks, Jennifer. My name is Bhaskar Ramachandran. I'm the LAADS DAAC project scientist. I got glimpses of the sort of question that Jennifer read, and it's certainly very interesting. And I must admit it's out of my bailiwick, but certainly if you can send it to us, there's a number of people that I can think of who work with such problems, and I can definitely get you a more authoritative answer. And I myself don't have one.
Well, that's kind of what I expected because the topic is really, thanks so much, Bhaskar. The topic is really kind of outside of the scope of today's presentation, but we really appreciate that input. And just as a resource for everybody, if you ever have a a question about any of our enterprise tools or Harmony or any of NASA's Earth science data sets, one really great resource is to go to the Earthdata forum, and you can find that at forum.earthdata.nasa.gov. And that's really a great place to go to interact with both science team members, subject matter experts from our discipline-specific data centers, and with one another, right? To interact with your science community. So that can be a really helpful resource just in terms of being able to filter by certain keywords or various tools. And so I wanted to throw that out there as well. Let me see if we have any additional questions in the Q&A. Yeah. Oh, thanks. Sorry, Cassia, you already mentioned this. All right, the next question. You used a bounding box for area subsetting. Is it possible to use an irregular feature like county boundary for subset?
I guess I couldn't answer this one. It's the feature is there. It's just not connected to Harmony API. You would have to do it using a shapefile. So it's available. Other services are able to use that, but it's just not connected to Geoloco at the moment.
Well, thank you so much for that response, Christine. And again, I'm doing a quick scan to make sure I'm not missing anything. All right, everybody. All right, well, while we are waiting for any additional questions here, we'll give it a few minutes. Again, I will send the recording link and the presentation slide deck to everybody. And if there are no additional questions, what we'll do is we will log off from the audio component and we will leave the virtual meeting space open an additional 10 minutes or so, although I think I saw something coming in. Okay, great. Thanks, Tasia. Appreciate the further clarification. We'll leave the virtual meeting space open an additional 10 minutes. And if you think of something that you'd like to ask our speakers, please feel free to note that in the chat or the Q&A. And yeah, they'll be able to follow up with you offline. And thanks so much for your feedback on the optional polling questions. We really appreciate that. Okay, one more look for questions. I do see a question, I think, just came in. So give me just one moment. I think that was posted in the chat. Ready? I have a question. Is there any link between Google Earth Engine and the Earthdata? What about its quality? So Doug or somebody else may want to weigh in as well, but there are quite a few NASA Earth Science data sets available through Google Earth Engine. I don't know, Doug or Christine or anyone else, if you wanted to add to that response.
Yeah, I was trying to get my camera to come on, but I'm going to talk, but it doesn't seem to be working. So you're stuck with just audio only. It is true that some of NASA's Earthdata cloud data is on Google Earth Engine, but that is something that Google have done themselves. They've downloaded it from our holdings on the Earthdata cloud in Amazon Web Services. Regarding quality, we can't make any guarantees on whether the data that they have taken from Earthdata Cloud into Google Earth Engine is exactly the same. We assume it is, but for the highest guarantee of quality of Earth science data within NASA's Earth Science Data System, then going directly to AWS and S3 buckets via the Common Metadata Repository or Earth Data Search is the best guarantee of that.
Excellent. Really appreciate that response and additional information, Doug. All right, there you are.
I got my camera working.
Okay, perfect. Let's see here. I'm just looking to see if we have any additional questions. All right, everybody, give me a second I was just checking the chats, but let me hop back down to the Q&A. All right, yes, we do. It's perfect. So, Katya, you already answered. Okay, is it possible to automatically download from the platform by programming?
I can take that one too, if that's okay. Yes. The common metadata repository allows you to determine via an API call what the latest data for a particular collection is. So using that, you can then turn around and acquire that data through whatever programming language you see fit. If you're using Python, the Earth Access library is very useful in this respect. You Google Python Earth Access, you can find it. We are in the process of providing more comprehensive functionality in this way, where you can subscribe to AWS SNS topics, so that that are scoped to a particular data set, so you will be automatically informed when new data is added based on your particular criteria, and you can add infrastructure around that message to consume that data as it has been made available to you and notified to you by that a message on that SNS topic.
All right, perfect. And I did actually place a link to the CMR in the chat for everybody. Okay, still scanning here. All right, the next question is, will the Geoloco have the capability to stack multiple products for multidimensional time series analysis?
Unfortunately not. All of our data does not have time different. I mean, I guess Bhaskar or Sashi, we can answer more, but we don't have any like data that is or temporal, basically. So all our data is just have like a one time.
All right, well, thank you so much, Christine. All righty, taking another look here. Yep, thank you, Doug, for a link to the Earth Access library in the chat. I don't see any additional questions. And so if there are no additional questions, for those of you who might be interested, next week we are hosting it's the fourth in a series of discipline-specific ISAT 2 data training workshops. This next week, it'll focus on sea ice products. And if you go to earthdata.nasa.gov, you can register for that event. Okay. I don't see any additional questions. So with that, I'd like to thank our Q&A panelists, Doug Newman, and thank our folks from LAADS DAAC, Sadashiva Devadiga, and Bhaskar Ramachandran, and our speaker today, Christine Brown-Stevenson, and Tassia Owen from LAADS DAAC. And last, but certainly not least, my backup host and science writer, Joseph Smith, for all of your contributions this afternoon. And thanks to all of you for joining us, taking time out of your day for this training. We look forward to seeing you at an upcoming event. And with that, we're just going to do one last check. I don't see anything else. We'll log off from the audio component, and I will leave the virtual meeting space open 10 additional minutes. All right. So thanks so much, everybody. We appreciate you, and we'll see you at an upcoming event. All right. Take care now.
All right.
Goodbye. Thanks, everybody. Goodbye now.
Bye.
Bye. Thank you.